Okay, so last Tuesday, I was on the Homebrew Robotics meeting, and Camp PV and I were the only two on there, and he was trying to figure out trying to figure out a gazebo model to model his robot that he's trying to build. He's trying to build a physical robot. First of all, he's trying to write a book on doing robotics, and he's got like a Roomba type robot that he's put together, and he's converting that over to run on Ros 2. And I believe it has a Raspberry Pi 4 inside of the thing as its computer type stuff. And now he's looking at trying to do simulation in Gazebo. So he had a question. He was looking at the Lino robot package, and let me just post all these links at the same time here if I can make this work. Chat. Let me go to here. That doesn't seem right. Okay, we'll see if this works. Come over to chat, paste that. And did it post everything? Oh, I have to hit return. Okay.
Yep. It's all there now.
So let me see if that came through the way I wanted. Yes, it did. So we were going through trying to figure out, he was trying to change numbers he wants to change put on larger wheels and change the spacing, because the original one and the Liner robots had like 3-inch diameter wheels, and the thing was like, I don't know, 5 or 6 inches wide or something. And he wants to build a bigger robot. In fact, he has an old Zagros. I think it's Zagros Robotics, which is like a round, made out of round plastic plates that are like 12 inches in diameter, and it has like lawnmower wheels on the thing, so they're like 5-inch diameter lawnmower wheels. So essentially, he wants to duplicate that. So he just wanted to go through and increase the size of the wheels, and let's see if I get these out of the way. And go to this page. So if I say share screen, this screen. So we had this screen up, and it's just one of the mini Zacro files that are all tied together here. And in here, it's defining properties. So properties is an extension you can put on top of on top of everything else that's there. It's essentially like in Python or C, where you're doing a define or just creating a variable. So here, it's just assigning a name of base length to a value of 0.24. So what he wanted to do was he wanted to increase the size of the base, and then he was trying to get his wheel. First of all, he wanted to put the larger wheels, change the radius and the width of the wheels, and then he's trying to figure out the XYZ positioning for where to put the wheels onto his vehicle. So after he makes the thing larger, he was just trying to figure out where all those go. And he was trying to change these numbers and get it to respond with, when he loads it in either into RViz or Gazebo, he could see the differences. And so we went through some of that. And so what I did after the meeting, I got on, I spent all day yesterday on YouTube and on the internet digging for stuff, and I came up with like 50 different links to various tutorials on what people were doing. And that first one that I pulled up is this video here, which actually go to is, first of all, he's got no, let's put it this way. I've got this video and this web page. So this web page, he's go through step by step and basically tells you all the things you need to do to build this thing from scratch. So you build the box, then you put wheels on it, and it tells you where to put the pieces and everything on this. So this is actually the second link that I put on there, the one that says creating a rough robot for Gazebo. And I think that's what this website was. So anyway, that's got a YouTube video associated with. Oh, there's the. I was trying to look for the icon for that video. Well, that's what it would look like when you pull it up before you play it. So you go to the video, and he's got a 27-minute video here, and he takes you through step by step. And he's not doing anything extremely fancy. If we go back and look at the thing here, He doesn't even put in the properties that we saw on, where did that go? This page. So he's not even using the property concept. He actually says if he wants to create a wheel, he says we're going to create a wheel. We're going to generate a cylinder. You have to flip the cylinder on its side because Ros or Gazebo, if you create a cylinder, it's laying down on its face. So you have to flip it up. So you have to rotate it around the x-axis by 90 degrees or pi over 2. Or as the British guy says, pi on 2 is how he says pi over 2. So there's some little idiosyncrasies about listening to a British speaking person that kind of annoyed me, but I got used to that after a while. So anyway, he goes through step by step, create the cylinder, flip it on the side, and then figure out, just measure where do you want this wheel to be in space. And he puts the actual physical numbers in there. And then there was something else associated with that. But he takes it through step by step. He says, create a wheel. You have to create the visual section. You have to create the collision section that tells Gazebo if you're driving around, you run into something. That's how it knows that you've contacted something. That's what that section does. And then there's a section called Inertia. And I guess there is one thing that he did. He created he created macros for inertia. So you say, I want to create the inertia for a box of this XYZ size, and it does all that for you. Whereas the next thing I'll go on to here of the when I get on to the actual Ros documentation, they did not do that. So they've got this big block with this big matrix they put in there, and that gets around that. So one of the things I ran into is you look at multiple tutorials. If you go through each one, they do it all. Each one does it a little bit differently. So when it started off here, if we go to this guy's video, let's go back to here. Stop it. But if you go watch this guy's video, as I say, he takes you through step by step. He says, we've created a file with just baselink in it, and then he creates the chassis, which is just a box. He creates the visual for the box. He creates the collision and the inertia for the box. And then he says, okay, now we're going to create a wheel. Now, it turns out you have in URDF, you have joints and links. A link is a physical object, like say a box or a wheel or just a connection or not a connection. Just anything that goes in there is considered a link. And then each link has a visual, the collision and the inertia associated with it. I think you can put more things on, but that's what he was talking about here. So he went through, created the box, created one wheel, created the other wheel, and he's just physically placing them where they needed to go. And then he says, okay, let's create a caster wheel. He just created a sphere, again, of whatever size he wanted, and then said, okay, we need to put it at this XYZ with these rotations. And essentially that was the end of, he spent like a half an hour go through and telling you how to do that. And if you look at this website here, that's the steps he's talking about doing here. So that's how that all went together. Now he has another video that starts one previous to this, and it's talking about, let's see, it's simply called Urdf Example. And if you go, so here's the code for that on this GitHub. This would be the first link that I posted in chat. This is the GitHub, and he's got the sample code in there. And I guess he does have some description down here what he's doing. And this is what if you search for it on YouTube, this is what shows up. This is what the icon looks like. So then he's got a video that's, again, about a half-hour video. And he creates this thing. Let me just see if I can find. Yeah, I guess. So if we look right here, he's saying we're going to create this thing. Can you hear the audio coming out of that?
I can hear you. I can't hear any audio from the
video. Okay. I guess I don't know how to do that. It seems like that should work. But anyway, so he says this is what he's going to create. He's got this base plate that's just a solid piece. And he's got this block on top that's a slider that can move back and forth across the surface. And then he's got this arm that's pivoted right here. So you can raise and lower that arm. And this on the end, he's just got a camera a simulated camera that he put on the thing. And then if I find, So here he's showing. Here he's showing the different pieces. So he's saying this down on the base. This is base link that's defined. That's just basically the center of your the thing that he's starting to create. And then this is the block that slides back and forth. And then he's showing the arm lifted up, and then he show the camera. So these four transform markers are just showing you basically the origin of each one of these things. And then as it moves on here, then he says he's creating 4 different types of joints. So you can have a fixed joint, like say when if you're telling your vehicle you've got a GPS and it's located a certain distance from base link, that becomes a fixed link. So it says the parent link is base link, the child link is GPS, and you create a fixed link between those two, and that just tells it where to find that on the vehicle. And then you can have the prismatic. I don't know why they call it prismatic, but that means it's a linear joint where the thing can move back and forth. And he used the example like a linear actuator. So if you have an electric linear actuator, that's how you simulate that. It's just a point that moves straight in and out. And that's how he does his slider on top of his plate. And then the revolute joint it's an angle. So in this case, he's showing in the arm here, and the revolute has a minimum angle and a maximum angle. You can define those. So it's a constrained rotary joint. And the one down here called continuous, like you'd put on a wheel, there is no constraint. So it can roll continuously forward or backward as far as you want it to go. So he goes through and says these are the 4 types of joints he's going to use, and then he puts it together on his little simulated thing here. Let's see if I can come up with a picture of it. So this one just goes through and basically gives you the steps. It says if you want to get started with URDF, so right here, I'll run this, but I won't have any audio. This is what it's going to look like when he does that. And at this point, he has something called Joint State Publisher, and it's some kind of a GUI. And apparently when you start this up, you can assign little sliders on here. You can assign those to, he's got one that's called slider joint and one that's called arm joint. So as he moves those sliders back and forth, you'll see on his thing, this blue thing slides back and forth on the plate, and then his orange arm raises up and down. So I'll go ahead and run this. As he moves those sliders, you can see it do that. And he just made the comment, he says, and you can imagine there's a camera on the end. So he just takes you through all the steps to build this from scratch and says, this is just a hypothetical thing you could do. And it's just there to demonstrate the types of joints on this thing. And then he builds the whole thing. And I don't remember if there's anything else significant to it. But anyway, he goes through step by step, and it's best to start with this one, just so you know what the terminology is, and you can see how the pieces go together and so forth. And then you move on to his second video, which was, see if I can find some interesting pictures here. So basically he's building, so here he's building this vehicle where the box is his chassis, and then he's got a wheel on either side. And he's pointing out that base link is in the center of because base link you want in the center of your 2 wheels. So he did that. And at some point, I think he was shifting his box back and forth to make it match. Now, it might have been a different video I was watching that was talking about that, because I went through a bunch of them. And again, the more videos you watch, you can say, okay, one guy did it this way. You watch the next guy, and he'll do it a little bit differently or tell you something different. So it's good to go through several. If you've got the time and you've got the inclination, it's good to go through all that. And then on the bottom is his caster wheel, which is actually a sphere. And so technically the sphere should be shown up here. This might be like a simulated CAD drawing. So anyway, this is what he's building. And then when he runs it here, this is just another example where he's actually moved this slightly off center from the, so he slid his reference point for the box, the chassis, its 0, 0 point is down here. And then base link is part way. It's not actually in the center of the thing, but he just picks some numbers and we'll put it there. And then when he puts his caster wheel on, he just sticks it back here somewhere. So that's just another intermediate shot. And I'll try to find one in RViz here. So here it is in RViz where he just said, here's the box that he created, and here's the transform of the 0, point of the chassis at one end. And he also says chassis or something is another British pronunciation. And then this one in the middle, this is his base link, which is not in the middle, but it's also not at either end. So that's his first thing he did in RViz, was to view that. Then come down here. Here's what he's talking about, the fact that when you create the wheel, it creates it laying flat down on the surface. So right here, he said, when you create the wheel, it's laying flat down. So what you have to do, he says, you have to rotate it around the x-axis to get the wheel to stand up. So he goes through the steps here and tells you how to do that. So here he's saying, he stands it up and makes the comment he wants his z-axis pointing out. So you could either do it pi on 2, as he says, or you can do minus pi on 2. So you could flip it either direction, and he wanted his z-axis pointed out. So he did it this way. So he explains those steps. And then we come down here. So here it is. Here it is in RViz. So again, you got the box, you got the two transforms. This one's base length. The one in the back here is the reference point of the box. So now here's a wheel stuck on, and you can see the transform for the wheel. And then a couple steps down here, he'll pull up that joint state publisher again and use a slider, and you can see the wheels turn here. So I'll see if I can find that. And this makes a lot more sense if you're actually watching the thing instead of me just poking at it here. What's this one here? So I'm not sure what he's about to tell us here. He's just looking at it from various angles. I was hoping I could find that one where he's actually showing the wheels turning, but I don't see that. Then out here towards the end, he's actually going to start it up in Gazebo. So this is still in RViz at this point, I think. Where's his controls? Well, I guess I don't see it showing up in Gazebo at any point. But once you get this model created, you can then spawn it into Gazebo. And he makes a comment at the end during the wrap up. He says, well, he ran out of time. So the next video he's going to then pull this into Gazebo and show you how the thing works. But at this point, he took you through all the steps to create the pieces that you see there. And to me, that seemed very beneficial. He didn't put a lot of extra stuff. He didn't put the properties, which then get stuck into the code down below. That's what we'll look at next. But anyway, I think that's a useful thing. But if you start with if you start with this one that just introduces you to URDF and watch through that one, and then you move on to this one where he tells you how to build the actual little robot. And then something that Camp had pointed out, if you go to navigation 2, this should be the third set of links that I posted. And under navigation 2, there's something called setting up URDF. Now, this is going to take you through the same steps that this guy just did. And he comes down here and he introduces the concepts on this one of, he says, we're going to build something that looks like that. So it looks almost identical to that one we just saw. And blah, 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 blah. So he introduced the concept of properties. So you create a Zacro property and you give it a name, so the base width, and then you give it a value. So this just simply is assigning numbers into a property, and now the property can be used in the code just like a variable, is what the point of this is. So this is introducing one more thing on top of what the previous guy just did. So you go down here, and so you got those defined. So he's going to create the robot base. He's going to create the big box that's going to define his chassis. So down here, when you under the geometry tag, and again, if you go through the previous one, he's talking about what all these different tags are. So under geometry, you're going to create a visual box. So you use the box command, And here for size, instead of putting in values for X, Y, and Z, he's putting in the numbers the properties that he created up above. So basically what this means is you got this big chunk of code, and then at the top, it's just like on a header file on C, where you go change the numbers in the header file, and then those get introduced into the code. So here he's just simply saying, make a box and give it a color of cyan. And here's another interesting point where he's saying RGBA, and he's putting in the actual numbers to create the color that he wants. Or the previous guy had macros for his colors. He said right up front, I'll create a macro for red. And then he put in these types of numbers to make it red, and he made one for blue and one for white and one for black and so forth. So then in his code, he can just say, where it says color, he can just say color red, and then it'll show up. So again, between these two tutorials, they're showing you different ways of doing stuff. And that's why it's good to watch multiple tutorials. So let me come down a ways. And let's see, base footprint, robot footprint. So here he's just projecting his base link down onto the ground to give him a base footprint. And here he's just defining it as he's putting X, Y, Z values, and the vertical distance is his wheel radius plus his wheel offset. So again, he's taking the numbers he defined above and doing a little bit of math to fill in the numbers instead of putting in a number like 0.5. He's actually doing calculations based on two of the numbers above. So that sets up his base footprint. And then here he's defining a wheel. So whenever you do this stuff, and the previous guy explained all this, you've got a section for link and a section for joints. So in this case, under the link, which is the physical object, it's going to define the picture of it. So they're going to say create a link, and here where it says prefix, that's another thing where it's either going to be, the prefix is going to be set to left or right as this thing runs. So again, they're using the macros to introduce more automation into the whole process of building this. So when it says the name is going to be prefix link, so that's probably going to say left link or right link, or it might say left wheel link or right wheel link. So it's going to create a name called that. And then under origin, it's going to tell it where to place it in the world, where it's going to place it on the vehicle. And then under geometry, he wants to create that cylinder. And again, he's pulling up the values here of, let's see, how can I scroll this? Well, maybe I can't. Well, that's not working out. Anyway, back to the wheels here. So the geometry creates the actual physical wheel. And then this thing about origin, here's where he's doing the rotation around the x-axis. He's doing the pi over 2, so it's going to rotate it by 90 degrees, and the origin is going to be 0. And then somewhere it has to place it actually on the vehicle, and I don't see that. But anyway, the point is he's taking numbers from up above and sticking them into the code here as labels or variables instead of actual numbers. And then again, down here for his color, he did so set up gray. He put some numbers in. The previous guy had a function that, or a macro that said gray, and he preset the numbers, so it just makes it easier to do that. So the other thing with your wheels is the joint, and the joint is he's doing a continuous joint, so it's going to be the bearing on your wheel. So you've got a physical wheel defined, and you're going to connect a rotary joint onto that. So he's saying create that, a type continuous, and the parent link is base link. So he's referencing this, the base link on the vehicle, he says that's the parent, and then the wheel is going to be floating out in space here somewhere, and that's going to be named. Again, this prefix fills in, so it's probably going to be like left wheel link is the name of that. And then here's the origin. He's going to reflect. There's another point here where you have the wheel on the left has to turn one direction and the wheel on the right has to turn the other direction. So they come up with this concept of reflecting. So you say, I want to reflect one wheel as opposed to the other. So one of them is defined as the normal wheel to turn forward. And then when you do the other wheel, it'll reflect it. It'll just basically spin it around 90 degrees. So it's going to actually turn. When you say go forward, they're both going to go the right direction, but technically one's going backwards to do that. So anyway, that's something you'll notice. Now, the previous guy wasn't doing that. He just simply said, create this wheel, and everybody was happy. So this is adding on to the fact of doing that. And then down here, this actually instantiates it. So this says, here's where he's filling in those things. I set up above, it said prefix link. So it's going to run it once and say prefix is drive wheel, HL. So it's going to be drive wheel left and drive wheel right is what he's defining. And then the reflection, it's either reflected or not reflected. So it'll run this line, which calls this chunk of code and builds one wheel. It runs the next line and runs and fills in these, runs that code again to build the other wheel. So that's, again, it's going through step by step, telling you the stuff. And he defines a caster wheel. It's just a sphere. And let's see, front caster. He might have put 2 caster wheels on this by the time he's done. So again, you just define a sphere of the size you want, and you place it on the vehicle at whatever origin you want. So then at that point, he said the build and launch. So apparently it's going to run here, and it tells you how to do some ROS stuff. And this is done in ROS 2, so it's going to be a little different if you're doing it under ROS 1. So I was just looking for a picture here of it actually running. So here you say, okay, now he got that built. He's going to pull it up in RViz. And so he's saying, okay, here's what it looks like in RViz. So again, he's got his box. He's got his left wheel and right wheel. Or did he do them? No, this is actually left and right because he put this caster in the front. So his caster just showing up as a sphere on the screen there. And then I think, so he's doing the same concept here. I'm not sure what he's using, but he's got the sliders. So as to move the sliders back and forth, his wheels will actually turn based on that. Now, before you're done, once you get this thing all running, adding physical properties. Oh, so I said before that when you create something like a wheel, you create the link, creates the object, and then on that you have a visual section, you have a collision section, and a inertial section. Here he's talking about adding on the inertial part, and he's got this weird matrix to do the inertia stuff. The previous guy had a macro to do that, so he said create a macro for box inertia, one for sphere inertia, and one for cylinder inertia. And he took all the code out of here and put into that. So when he did it, he just said, I want to create, when he's creating his wheel, it says, I'm going to create the inertia for the wheel. And he just passed it the diameter and the width of the wheel. And this thing did all these calculations and returned them for him. So again, by piecing these things together, you can come up with the way you prefer to work, the way you want it to work. So here they're just saying, create the inertia section for the box, create the inertia section for whichever wheel this is. Cylinder inertia. Oh, so this is creating it for the wheel itself, and this creates it for the sphere. And now that I look at it, he's creating macros. So he's doing the same thing. He's creating a macro for it. So then later on in the code, he's going to say, for the wheel, generate the inertia of this diameter and this width. So that's probably what he's doing here. So he's saying he executes box inertia, and he says the box is this size. I don't know what M stands for, but I think M is mass. And that's some arbitrary numbers you have to make up when you're building this thing. So he's just passing it the height, width, and length, and it goes into the code, and it does all the inertia stuff for you. Now, collision is just simply, it's putting a box around whatever object you created. So in the case of a wheel, you put a box around it that's also a cylinder. So if that invisible box touches anything, that tells Gazebo, oh, we just had a collision with something. Basically, we ran into something. So again, if you just follow through, he just takes it through step by step. And let's get down here. So again, he's showing that in RViz again. Conclusion. So he doesn't actually pull this into Gazebo. So probably if you follow through the index here, this is setting, he's just saying setting up the URDF, and now you can display this in RViz, and you should be able to pull this into Gazebo as a model and run it there. So probably if you follow down here, one of these steps is probably actually running it in Gazebo. So now the thing was, if you go through these two tutorials I just showed you, they work slightly differently, but they do a very good job of explaining what they're trying to do, just to create, what do you have, four objects stuck together to form a simulated robot. So now if we move on to Camp was looking at the Lino robot stuff, and they've got the point where you've got multiple, they've predefined multiple robot types. There it says 2-wheel drive, 4-wheel drive, Mecanum drive, or Ackerman steering. And it turns out when they went to Lino Robot 2, which is the stuff for Ros 2, they dropped the Ackerman steering on that one. But when you go through the first one, the Ackerman steering was a physical, like a radio controlled car, and they did not do a gazebo simulation of Ackerman steering anyway. So it's not really a big deal. So if we move on, the only thing I can find for Lino Robot 2, or Lino Robot 2, is the GitHub. So you go to the GitHub. Let's back up to the main page here. So on the main page, that seems to be the main documentation for Lino Robot 2. This is the Ros 2 version of it. So again, you've got, various directories and stuff. And then under the README down here, they do have various, instead of having a web page with all the stuff on, they list it out here, and they give you a fair amount of documentation here to see this. So it says how do you install it, and here's the 3 types of robots they support. But now I believe he's got a gazebo simulation for all 3 of these types. And when they say 4-wheel drive robot, it's actually like a skid steer. So it's got the 2 front wheels and the 2 back wheels. The 2 on the right are tied together and 2 on the left are tied together. So there's no steering involved. It's just a matter of skid steer. And then he's got various sensors you can add on to it here. And again, you could hook up the real sensors, or you could do the simulated ones in gazebo. Just looking down here, say he's got any more pictures of what's going on. Here he's talking about here's where getting into the URDF is what we were talking about. So he's got a section here telling you how to do this. And I'm not sure how much step-by-step he goes through here. But the point is, so it says defining the URDF. And then if we move in, he's got the concept here. He's got multiple files that get included together to run this thing. And the first tutorial mentioned doing that. And then I don't remember if the Ros one, I don't remember if he had include files or not. So, but anyway, that's by using these Zacro extensions on top of URDF, it lets you create macros, it lets you include external files, and lets you do various other things. So he's got one file here that's essentially the parameter file. What does he call it? He calls it the 2-wheel drive properties, URDF Zacro. So under there, again, he's defined properties. So he's got a name and a value associated with that. Now, these may be slightly different than the previous tutorial we just looked at, or this may be identical. I haven't looked at it hard enough. I was putting this together like 2 minutes before the meeting started, so I'm not sure exactly how these compare. But essentially, you start off with these, and you can change these values here. So if you want to change your size of your wheels, here's the radius and the width of the wheel, and then the XYZ position tells it, basically how wide you're going to space your wheels out, and so forth. And then he's got a couple other things. He's got apparently a laser on it, and a depth sensor. The depth sensor might be, we'd have to go track that down. But the point is, so it's got one file just defining the properties, so you don't have all the other code and stuff getting in the way. And if we go look at it, so you say, well, how do you use that stuff? Well, here's a file called base URDF Zacro. So this is another one of the include files. And the base is simply defining the box that's going to be your chassis. So it pulls in. So when you start this thing, it says Zacro macro. The name of the macro is called base, and it's going to import these values from those properties that we just created. So anything you put here can be used in the code. So it says the link name, base footprint. Let's see, base footprint, link. So I think that's just simply saying base footprint is the origin of this. I'm not sure what that line's doing. Next one says link name, base link. Well, this is actually creating the box, I believe, at this point. So So I think he's calling the box itself, the chassis itself, he's calling it base link, whereas other people will have a base link and then create something called chassis and link the two together. It looks like in this case, he's got a box and he's calling the box base link. And again, you just give it the, under geometry, which is going to create the visual part of it. It says we're going to create a box of this size, length, width, and height, and that just builds that box for you. And here the commented out thing is pointing out you can, instead of creating the box that way, you can use a mesh to replace that. So if you want to go in a CAD system or go in something like Blender and make a fancy looking body for your robot, you can do that, export that as, I think, as an STL file, and then put that in your mesh directory. So he's saying if you want to, you can create that instead of creating a physical box. You point to the mesh file and you give it a scale so you can make it bigger or smaller to fit on your vehicle. So that you can do one or two ways to do that. So like in Al's case, he could go into Blender or something and build all the pieces that look like his lawn tractor. So he could build an engine, he could build his, I don't know if he, I think he took his seat off. He's still got the box in the back where that was. He's got a big plastic box on with electronics. He's got a post sticking up with his GPS on. So he could model all of that in something like Blender and get a nice fancy 3D rendered image and then store that out in your mesh file. So instead of creating a box for your chassis or instead of doing that for your chassis, you can import this image and you'll have a real fancy looking vehicle at that point. So that's one of two ways you can do it. So here again is the, he said material name is yellow. I guess he is physically defining. Oh, no. So this guy again is defining the actual numbers of RGBA to, in this case, he wants to create something called yellow. So he wants his box to be yellow, and he's giving it numbers here to do that. Whereas the first guy created macros, he had a macro called yellow and had the values in. So you could just say material color equals yellow, I think, at that point. So this defines the box by importing the height, length, and width, and then the collision. One of the people points out that basically what you can do to get the collision to just blatantly copy whatever you did in the visual part of it and call that collision, and that way you've got an invisible collision box over the actual object you created. So again, by watching multiple videos, the guy points out, yeah, you can just do it. You just blatantly copy this, or you copy this part and put it down here. He's got some extra stuff stuck in there, so it's not quite the same. But the first guy made it very obvious you can do that. So it's not, you don't have to think all this stuff up. Now here's the thing with the inertia. Here's this big matrix you have to make up and go look it up to see how this stuff works. But the first guy just made a macro that says, create the inertia of a box. So he just says box, mass, this, and XYZ size, and it generates all this junk for you. So again, by digging through the different examples, you can decide which way you want to do that. So that's how you pulled in. That's how we're going to create the box to make the chassis on this vehicle. And then we got the section. So gazebo base link, visual material. This is all kinds of extra stuff you can add. So you can set how shiny the surface is, and I don't know what ambient means, but the diffuse is whether it's going to reflect or not, and specular is, do you get the specular reflection? So you've got the light shining on, you get a spot on there showing you where the reflected light is. So there's all kinds of extra stuff you can add if you really want to. And again, that's just basically extra window dressing at this point. If you just want something that drives around, you don't need all this extra fancy stuff. So then the other thing, so on the box, you have to have a link, which defines the actual physical box. Then you have a joint that's going to connect it to whatever else on the vehicle you want. So here he's going to connect the base to base footprint. So instead of going back to base, the box is, he is calling the box base link. Instead of calling it chassis, he called it base link. So here he's just equating the box itself, which is called base link, to the parent, which is base footprint, which is the projected point down onto the ground. So this is simply creating the what do you call it, the fixed transform between those two. And then down here, the origin, he's just telling where on the vehicle you want that where you want those transforms to be placed. So that's how he created the, by using his properties, he defined the numbers, he pulled them into this thing, this generates his box. And a slightly more fancy one, we'll look at how he does the wheel. And this, I believe, stop it. This one is wheel URDF Zacro. So this is going to create a wheel. And again, at the top, he says, here's a macro. It's called wheel. And he again pulls in the variables that he wants to use. So this block right here will create one single wheel. And then there's that thing we were looking at before where it may say mirror. No, you call it reflect. You might want to reflect one as opposed to the other. And you might want to specify whether it's the left one or the right one. And then they'll stick those variables into the code as it goes through here. So again, it says pull in all these variables we want to use. The link name. So the side is going to be left or right wheel link. So somehow, I think down at the bottom, it'll pass in. It'll say, I want to create a wheel for the left side. It'll call this macro, and it'll create something called left wheel link. And then for visual, again, it's going to create the picture of it. So under geometry, it says we're going to create a cylinder of this radius and this width. Now we want to make the color blue, and the origin. Here's where he's rotating the thing to stand the wheel up on it make it stand up vertical. So that's creating the actual visual part that you can see. Now under collision, again, if you didn't have extra fancy stuff in here, you could just copy the visual and paste it under collision and change the name. So it's just creating a surrounding box around your wheel. So if we touch anything, we know we ran into it. And then under inertia, again, he's got this big array here. So go back to the first guys where he's got the macro to generate this. So you just say inertia wheel and give it the dimensions of the wheel, and it magically generates this for you. So now under gazebo reference, what's the gazebo reference doing? Joint name. So if you, on these tags here, if you say joint, it's creating a joint like a linear prismatic or a revolute rotational joint or a continuous rotational joint or a fixed joint. Well, under so that's what joint is doing, is creating one of those. So that tag, you got a joint start tag and a joint end tag to create that. So we'll skip over this stuff up here for the moment. And it's saying we want to create again, the side is passed in either left, right. So in this case, we'll say we're going to create a left wheel joint is going to be the name of it. And it's going to be a type continuous. So you're basically putting a bearing inside of that wheel. And now what you're doing here is, so whenever you create a joint where it says axis XYZ, you're telling it which of the three axes you want it to rotate around. So in this case, the rotational joint, they're saying we want it to rotate around the Y axis. So after you flip this thing up on the side, it's going to spin around. So it's going to, yeah, that's the axis it'll rotate around, is the Y axis. Now also notice this is a 1. You can make it a -1 and the thing will rotate backwards around that axis if you want it to do that. So that you either put zeros, ones, or -1s into here in whichever field you want. I suppose you could do 2 fields. You want it to rotate around a 45-degree angle or something. And then he's just saying this is tied to base link, which is his chassis, is the parent is base link. And then we're going to place it at the, let's see, child link side. He said we're going to call this left wheel link. So up here we said left wheel joint. Here we're saying the link, we're actually naming the joint. It's going to be called left wheel link. Or no, that's the physical wheel that it's tied to. So we're tying the base link to the physical wheel. And then you got to give it a position. So you tell it where on the vehicle you want that wheel to be. So essentially that right there it defines the wheel and tells it where to put it on the vehicle. And then the link here says the wheel, basically the rotary joint on the wheel will be tied to base link, which is our chassis. There is really no, if you look at, there's really no physical connection between that. You just know a point in space called base link, and then a wheel floating out here in space. And there's real, you will see no physical connection between that. You're just defining it by giving it the origin at this point of XYZ position. That just tells it where it is in reference to your base link. And then I said it was a skipper, it was gazebo. Again, it looks like they're just doing fancy things of adjusting the surface material to make it look either shiny or not shiny or whatever is all they're doing there. There is one more thing. I noticed if you look at, I was looking at the Prius, the Open Source Robotics Foundation put out a vehicle that's a Prius car, and the very first 2 or 3 lines in that, it was saying left wheel and said mu1 is 0.9 and mu2 is 0.9. And I think what that's doing is defining the friction of the tire itself. So again, since you got a full physics engine here, you can go in and you can adjust all the stuff. You can adjust the masses and the weights and how much friction something has. Either it's friction between the tire and the ground, or if you go through that first tutorial, he's talking about he's sliding that thing back and forth on the plate, and he said, well, it kind of jitters around, so he went and added some code that said add friction between those two, and that slows it, damps it, so it doesn't, if you move it all the way to one end, it doesn't go boing, 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 like that. It's got friction against the plate, so it comes down and stops and sits there. So that, again, there's a lot more stuff you can add on to this, but these are just simple examples looking at this stuff. And I think I had one more page here. I think maybe down at the bottom here. Now, I don't see it right offhand, but somewhere you have to have something that says, okay, instantiate a left wheel, or instantiate a wheel, and we're going to call it the left side. We're going to call it reflected or not reflected, and then call the macro to create a wheel, and that will build a wheel and place it. And the next line says, we're going to create a wheel, and we want to do the right side, we want to reflect it or not, and call the macro to generate a wheel, and that creates your second wheel and places it in space. So again, this is taking advantage of the fact they have lots of different include files here. They're putting these all together, and you have to go through and figure out which is the master one, and then that will then include other files as you go. So that pretty well. Oh, then the other thing is, once you get it to that point, you've got a vehicle that we're going to find a picture here. So you create this vehicle, and you've got a wheel here and a wheel here. Somehow you have to get those wheels to turn. You want to be able to have some kind of code that will drive those. So so far in the examples, they've just been showing a little slider on a tool they loaded in, and by moving that slider back and forth, you can watch it'll set the rotational angle of that wheel, so you can move it back and forth, but you can't actually drive it that way. If you had it in, say in Gazebo and did that, if you turn the right wheel, so you got the left wheel, the right wheel, and if I say turn this wheel, what it's going to do, it's going to turn, well, the other way. it's going to go like this. So the vehicle is going to rotate around the fixed wheel while the other one's turning, and you turn the other one. So that's really all you could do with it, is get it to just kind of rotate back and forth a little bit, because you don't have any way to talk them both at the same time. So I believe the next option is you would, and if you go back to the original stuff back when ROS 1 first started, they're giving tutorials, you have to have some way to tie these joints to some software that'll make them move. So one of the simplest things is you got this code here, or you got this vehicle built. So you go into your URDF file and you add a block of code that says, I want to add a Ros controller. And that would be under a Gazebo tag, and you say, I want to add a Ros controller, and you give the name of it. And typically you would say it's something like lib Ros control differential drive .so, something like that. You add that code in, and then under a couple lines under that, you have to put parameters. So you say, I want the left side to talk to whatever the joint name is for the left wheel. And another line says, I want to have the right side talk to whatever the joint name is for the right wheel. And then that magically figures out how to turn those wheels to make your vehicle move forward or backward or rotate. And that differential drive controller will subscribe to a command velocity message. So once you drop it into Gazebo and start it up, it just automatically subscribes command velocity. So you take your keyboard teleop or your joystick teleop and start generating command velocities. And then that little plugin you just put in there will interpret that and start turning the wheels, and you can now magically drive the thing around. So now that's all well and good for a little differential drive robot. So now I want to build the 4-wheel Ackerman steer vehicle. And it looks to me like if I make the back wheels work just like the wheels on a differential drive, essentially I instantiate them, put them on the vehicle, and put them across base link. That takes care of the back end. And for the front end, you got one more detail, because you have to instantiate your two wheels. Each wheel has a bearing in it, but now you have to put another joint here. So looking at it from the top, say it's like this, but if you look at it from the top, then you have to have a joint here that the wheel rotates around like this. So it's basically one more step. You have to add one more joint in there in order to be able to turn the steering for the things. And then there's another point where some of the examples I saw, they put the pivot point right in the center of the tire, so it actually rotates around the tire like this. Now, in reality, like on my vehicle that's back behind me there, or on, say, the lawn tractors. Here, let me do this. So here you've got the, so you can have a wheel like this, and it pivots right around the center point of the wheel as it steers. But on like my vehicle or the lawn tractors or a full-size tractor, probably even on a car, the joint is actually out here somewhere. So the thing actually steers around like this, because you've got the pivot point here and a short stub axle that comes out to the bearing on the wheel. So you could do it either way. You can either make it steer directly around the center, or you could physically put a link in between there that says, here's my short stub axle, and make it rotate around this point out here. And a lot of that just comes down to how accurate do you want the physics to be. And you could do it either way, and either way will drive around. So then once I get it to that point where I've got the two back wheels that I can control with say joint states, change the angle of the wheels in the back to make it drive forward or backward. And in the front, I've got the two wheels on the front here. Now, by adding the steering joints, I can make them turn like this, but they don't turn at the same angle due to the Ackerman. So you have to have something to calculate that. And then still you have to get them, you can rotate the wheel this way to go forward and backward by controlling the joint states. So now, instead of using the differential drive plugin, you have to have an extra piece of software. And the thing I started with, that radio controlled car gazebo model I started with, he's got a Python script that's called Ackerman Controller, I think is what it's called. And that will subscribe to an Ackerman message, and then it generates all four wheel velocities and then publishes out on the joint state. So you calculate the speed of the back left tire, and then you publish that on the back left tire joint, and now that wheel will magically turn based on this Python program that's running. So he actually calculated all four wheels. Now, I don't know if you have to actually drive all four wheels, or you can go to the front wheels and say set the effort to 0, which means it seems like you should be able to get the front wheels to freewheel. So like on a lawn tractor, you drive the back wheels, but the front wheels are just basically freewheeling wheels. And on my vehicle, that's basically the way mine works too. So I've got, the front wheels are just have bearings in them. They just turn freely. And then to do the steering, that Ackerman Python program, Ackerman controller, reads in the Ackerman message and pulls off the steering angle, which is a value in radians, and does various calculations and says set your front left wheel to whatever angle you tell it here, and then set your front right wheel to whatever angle you tell it here. And then magically you've got enough stuff to make an Ackerman vehicle drive around. So it's just a matter of, my biggest problem was I started with that radio controlled car model, and I was looking at the Urdf file, and it was way more complicated than I could figure out, because they did all this stuff with putting in the left side, right side, and reflect, not reflect. And I was looking at trying to figure out how to change the numbers. Back to the problem where Camp was trying to change his wheel diameters and his wheel placement. And when you do the macro file, you can't see the code that's doing that, because you just got a number that says here's the diameter, and then magically down in the code it builds all the stuff on the fly. So I was in the same position. I was trying to change a number and see what it does. Now there's a trick you can do. You can say execute. I think you use Zacro -in order, and you give it the file name of the Zacro file, And what it does, it takes the macros and builds a flat file. It just compresses all those down to the point where you don't have any macros left in it anymore, and just outputs that as a file. So you can save that file to the hard drive and go look at it. And now I've got a section for the left wheel, the left rear wheel, a section of the the right rear wheel, and one for the front wheel, and then a front wheel, and one for the steering. So now you got the separate blocks of code. So then I can go in there and just change a number on, say, a wheel and see what it made it do. So that was another handy way to figure that out. So that's why I was back to the point trying to figure out, starting at the beginning, this very simplistic URDF file, and say, how do I build a wheel? How do I attach it to the vehicle? And then go the other direction and build back up to the point where I've got the pieces I need to build a simplistic 4-wheel Ackerman steered vehicle. And then by putting the properties up front, you can just go out and measure your vehicle and say, well, my back tires are 18 inches in diameter and 8 inches wide, and my front ones are, say, 12 inches in diameter and maybe 5 inches wide. You just plug all those numbers in and run it, and it should come up and give you a reasonable vehicle at that point, I think. So I'll make one more comment. I said that code that I started with came with a Python program called Ackerman Controller. Well, it turns out there is an official Ros Ackerman controller, but I look at it and I can't make sense of it. And our people are asking out on Ros Answers, says, is there any more documentation? Because I can't figure this out. It doesn't make sense. So I probably won't attempt to use that one. And there are a couple other official ones, or fairly official ones out there, but one of them then used something called hardware controller or something. So it's mixing lots more stuff together than I wanted to deal with. So I'll probably start with that code that I got with the radio control car and try to get it to work on my own URDF and see where that gets me. I do have that original one. I did strip it down to the point where I can define the individual tire sizes and the spacing and everything and run it with his Ackerman control code. And I can make a vehicle drive around the screen. It acts funny. The steering kind of flutters like this as it drives around. But again, I've still got parameters for a radio control car put into something that weighs 100 pounds. So it could be I just need to change PID gains or the inertia values or whatever. I didn't try to adjust any of that, but I do have something that will drive around. So either way, I've got a starting point, either start from scratch or use the one that I had extracted out of that original project. So I think I'm done talking about that.
Well, I'm going to have to go here in a minute, but I'll just share with you quickly where I'm at. So this is again my GIST, and there's two things I published or updated out there. One is just a test program. I wanted to make sure that I was understanding.
Okay, could you back up a second to the previous page and post that link to chat? That one, they could probably decipher that one as opposed to the ones that get the 23-digit long numbers, but. Well, you just posted. Oh, okay. Oh, I see what you did. You posted the one for the Prius car, apparently. Okay.
I did, yeah.
Okay, sorry to interrupt, but.
I need to update my low-level steering controller. That's based on Jeff had written a Python program to take your forward velocity and I always get the language wrong. So I ran this program and I got these results. and I'm gonna update my low-level controller with the what do you call this value? The angle.
I think they just call it steer angle.
Steer angle. And so I wanted to make sure I understood how that was working. And before I put it in the low-level controller, I just wrote this test program that's out there just to, that's not the right one, I don't think. Yeah, that is. It just takes in some values as example. You know, the notion is command velocity would be sending an angular velocity z value, and I just wanted to simulate what that, you know, how the logic, how the code would work. And so that's what's out here. It had to write a map function to basically take these two values and spread them over my steer angle or my angle sensor, which, you know, in my world, my angle sensor generates a minus 14,000 when it's fully left, and it generates a positive 13,500 when it's fully right. So you know, when command velocity gives you one of these types of values, it's going to then map that over that value. So anyway, the bottom line is a little bit of progress. The test program is out there, as well as, and the test program generated these results, which basically says, hey, if I get an angular z value of 0.85, I'm going to generate, you know, a minus 14,000. If I get something that's minus 0.76, I'm going to generate a 13,500, and it, you know, I'm confident that the logic works. And so then well, it should just be there at the top. Why isn't it there at the top? And so this is the code that I put on my low-level controller, and my status at the moment is I need to go test it on the physical device. So this is the re-implementation of that in a function that I call steer base, and the map function is there. So a little bit of progress. Now I'm ready to test in the wild. The other thing I'll just share real quick is, I've mentioned before Joseph Linton. I think he's a really good author. He, back in October of last year, generated another Ros book. In there, Jeff was talking about URDF. In his book, why didn't that open up? Oh yeah, I guess is that it? No, that's not it. Why didn't that open up? If I went to don't make me fight with you. Anyway, in his table of contents, he goes through URDF as well. He does two URDFs. One is a simple robot with a box, two wheels, and the other is a articulated arm with a shoulder and an elbow and a wrist joint. So a little bit more complex, but the Joseph Linton book is out there. Those are a couple of things I wanted to share. Unfortunately, Jeff, I need to run.
Okay.
Have a great weekend.
Okay.